Our goal in preparing MAN BMW camshaft-less computer-controlled engine familiarization course is to have something for everybody, for all marine engineers, for serving and future marine engineers, for the educational purposes. This course costs a lot, so my intention was to make it affordable for all people, all engineers across the board, juniors, seniors, so that they can learn something. They can familiarize themselves. However, a voluntary contribution and donation is welcome, whosoever wants, whenever they want. And it's also encouraged. Also gives your feedback after you complete each chapter. That will help me make changes, improve the course, so that the other people can also can always get benefited. Thank you very much.
So besides other essential part and component of the ACS are LFE, electronic fuel injection. Electronic fuel injection valve is a proportional valve, which I told you, remember, there were used to be LV and LVA, different valves. So now fuel also, this part remains same. It is a proportional valve, and when directed by CCU, always the fuel injection to take place in desired unit and the precise time required. It's proportional valve because it has to allow the amount of fuel proportional to the given direction. ELVA was electronic valve actuation on the older engine. It may still be available on certain engine which you happen to go on the ship. If you join, is on off. It's only on off because exhaust valve need to be open and closed. There's no midway open, halfway open, nothing. Just I'll tell you now one thing, secret, not secret. In these engines, you can control the timing of the exhaust valve. You can open the exhaust valve little late, open the exhaust early, normally not allowed. No, normally it's not allowed. You cannot advance the timing of exhaust valve opening. Opening can be delayed by, of course, 1 or 2 degrees. Closing of the exhaust valve you can change. Closing. Advance retard both. What is the effect? What is the effect? I ask you a question. Think about it. Let me know. If you open the close the exhaust valve early, what happens to the engine cylinder pressures? If you open the exhaust, delay the closing of the exhaust valve, what happened to the compression pressure? I'll ask you later. Remember this question. Okay. All right. Fuel injection valve actuation. In older engine, LP was the fuel injection I just told you, and ELVA was for exhaust. And later on, what they did, they combined this. They made one, FIVA, fuel injection valve actuation. That's how they took the nomenclature, FIVA. Now, SU is a mechanical device and houses fuel pressure boosters, exhaust valve. You can call it booster or actuator. FIVA valve, cylinder lubricator, and accumulator. Accumulators are needed. Accumulators are needed. Why? What is the function of an accumulator? Any reciprocating pump need a accumulator. You must have seen your bilge pump. All right. So there is one SU for each unit. We shall, of course, learn little later. HMI, as I told you before, is a human machine interface. What is HMI? OMP. Operator interacts with HMI, that is OMP, to give command and changes parameter as required. HPS is a hydraulic power supply. Actuating power, FOPB, an exhaust valve booster is provided hydraulically and not mechanically. Indeed, because there is no camshaft. Nothing, no cam. And as in conventional engine. And conventional engine operates the fuel pump and exhaust valve actuated mechanically, here hydraulically. but they're doing the same purpose, function. Though referred to as hydraulic power, actually no hydraulic oil is used, actually some oil is used. Some oil is used for hydraulic power. So we use it because it's acting as a hydraulic power, so we're using hydraulic oil. Actually, hydraulic oil is not used, it's used some oil, that is marine and crankcase oil. You have to maintain the cleanliness of the oil, which is going to the as a hydraulic oil for hydraulic power. Actually, in some oil is drawn by the pump, lube oil pump as normal. One part goes to the lubrication as as it is now in the convention of a bearing and now piston cooling, etc. Other part goes to the control system, hydraulic oil. That part has to be removed, maintained clean and all. Okay. 6 micron filter is being used nowadays. Of course, there's a standby filter, 25 micron. So variable, of course, auto clean filter. So the hydraulic oil need to be sent for clean for the sampling also. So what's recommended are ISO 4406 earlier. Nowadays, ISO 447 standard are recommended to be followed. For hydraulic power, variable delivery axial piston pumps are used for raising the oil pressure to 250 kg centimeter square. Pumps are engine driven and motor driven pump. Of course, till the time engine RPM is picked up, then engine driven pump will take over. Motor driven pump then are cut off. All right. So this is about HPS, hydraulic power supply. Starting air valve. Starting air valve design remain of course unchanged. Starting air valve is same, exactly same as the conventional MCC engine. See, no distribution present. The pilot air is sent through the solenoid valve. A solenoid valve is controlled by the CCU. That is the only difference. It gets analog signal. Solenoid valve will open, allow the air to the start the air to the starting air valve. What was done by the pilot air, which is coming from the distributor. That is the only difference. All right. So, so advantages of the MBC engine are now quite comprehensive. Let us see, go through over it once again. Electronically profile injection. EPIC is online, continuous control of the timing of the fuel injection. Unlike fixed rate of rise of injection, pressure on mechanically controlled injection, fuel injection pressure, rate of rise on the injection pressure, and injection intensity is all controllable parameters. How fast injection pressure or how slow pressure shall rise, it is controlled. So we call it electronically profiled. Unlike CAM profile, which is once designed remain forever. Here you can change the profile as if you are using CAM on wish as per your wishes. Advantages. Of course, with the precision control, first thing which comes to mind is the prolonged period between interval between the maintenance overall of the units. Some ships it has been found up to 30,000 hours it has been run without overall, but no owners do that. We are still decarb we carrying out much earlier. Basically, they do it around 15,000 hours approximately. Once dry dock to dry dock also people are doing. Oh, depending on the hours engine is running. But dry dock to dry dock overhauling of the units is feasible. Ship staff is doing nothing. Sorry, sir. Much less work for the ship staff. Huh? Okay, lower SFOC and better performance parameters because of EPIC, lower specific fuel consumption, better performance, smokeless, SOx emission, of course, controlled by sulfur mount or the exhaust cleaning system, but NOx emission. All engine meet tier 2 norms. We'll talk about electronic control in timing of fuel injection, exhaust valve at very low load, also possible. Required fuel injection pressure and rate at any given load. Change of mode of operation even when engine running to improve emission characteristics and lower NOx emission. Meets emission tier 2 norms when running in emission mode, also economy mode. Economy mode and emission mode are two modes of operation of an engine. In both the mode, it meets tier 2 norm, but it doesn't meet tier 3 norms. In emission mode, NOx emission are lowered further than the tier 2 norm, but does not meet tier 3 norm. But tier 3 norm, SCR has to be used. HPSCR, LPSCR, as I explained, before the turbocharger, SCR put after turbocharger, or exhaust gas recirculation. Stable low load smokeless operation. Engine has been run up to 12 RPM, practically avoiding start stop. Bring to 12 RPM. Don't have to stop engine and again give a kick. Practically engine is stopped, ship is stopped. Okay. Chemical tankers which are running on in and out, much better. Retaining well-proven traditional fuel injection technology, that is same for MCC engine also. Engineers are well familiar with that. But increasing efficiency with epic control. Electronic control system ensures precise timing, giving better engine balancing and equalized thermal load between cylinders. System comprising performance, adequate monitoring, and diagnostic of engine for longer time between overhauls. Whenever the alarm comes, what is the alarm? What is the purpose of the alarm? How it came? What need to be done? What can be done? All is given on the screen. So engine can be operated by idiots? No, you still need to be a marine engineer. All right. With quicker and faster electronic control, ECS provide better astern and crash astern performance in emergency situation. Commands are followed quickly. As I said, practically overspeed cannot take place even in the rough seas. Because each cycle, number one unit, next firing order, fuel is calculated. Next firing order, fuel is calculated. As your propeller coming out of the water, each time unit fire a different amount of fuel, maybe lesser. Overspeed doesn't take place. Well familiar integrated alpha lubricator lubricator system available to crew. Many people are already familiar. Upgradable to future software development. Over the lifetime of the engine will be provided. However, it will be cost basis. Nothing is given free. So engine maker have developed the software and newer things are added up. So engine maker owner can take it, but most likely they will ask for the money to be paid. All right. SOx emission, which I told you about, which we discussed in the first module. So exhaust gas cleaning system, NOx emission. NOx emission tier 3 norms, you have to use HPSCR or LPSCR, that means selective catalytic reduction, urea or ammonia, you are used, or exhaust gas recirculation. All right.